An electron doesn't suffer any deflection when passing through a region of magnetic field. What is the direction of the magnetic field? We know if a charge is moving either parallel or anti-parallel to the magnetic field, then it suffers no deflection. Then the force experienced on the charged particle is zero. So here this is the case. This electron doesn't suffer any deflection when passing through a region of magnetic field. So the direction of magnetic field, that should be parallel to the direction of motion of charged particle, or it can be anti-parallel to the direction of motion of the charged particle. An electron is moving along the positive direction of y-axis. What is the direction of the force acting on it? If the magnetic field is acting along x-axis. So here it is asked that an electron is moving along the positive direction of y-axis. What is the direction of the force acting on it if the magnetic field is acting along the x direction? So that has to be added here. The direction of magnetic field is given along x direction. So just an application of Fleming's left hand rule. So in Fleming's left hand rule, we know that the middle finger should represent the direction of current, and in this question it is given that electron is moving along the positive y-axis. Electron is moving in the positive y-axis. So in this plane, in the plane of this whiteboard, electron is moving in the upward direction, y-axis. So we know the direction of current is opposite to the direction of motion of electrons. So if electron is moving in the upward direction, the current should move along the direction of current is along the downward direction. So aligning the fingers. So this is the middle finger, and it is given that electrons are moving in the positive y direction. So the current is in the downward direction. Then the magnetic field is along x direction, it is given. Then the thumb, we know 3 fingers should be aligned perpendicular to each other. So here the thumb is pointed away from the plane of the whiteboard towards away. So the direction of the force, that is along the positive z direction. Write an expression for the Lorentz force on a charge q moving with the velocity v in a magnetic field. So we know that when a charge q is moving in an electric field, it will experience an electric force F is equal to QE, where E is the strength of electric field. And also we have seen that when the charge is moving with the velocity v in a magnetic field B, it will experience a magnetic force F is equal to Q into V cross B, QVB sin theta. Maximum force will be equal to QVB. Then the total force, that is, if a charge Q is moving in a space where there exist both electric and magnetic fields, the total force experienced, that is the force that due to electric field plus force due to magnetic field, QE plus Q into V cross B. This is called Lorentz force. As shown in the figure, a charge is moving with a constant velocity perpendicular to uniform magnetic field. And what should be the magnitude and direction of the electric field so that the particle moves undeflected through the same path? The charged particle is moving in this direction, negative x direction, and magnetic field is directed into the plane of this board. Then we know that will experience a force. The direction of that force can be found by applying Fleming's left hand rule, or the direction of force is understood by analyzing the vector product. So here current is along negative x direction, unit vector is minus I, and the magnetic field is directed into the plane, that is along negative z direction, unit vector associated is minus of k. So V cross B means the cross product of vectors, so minus I cross minus k, so minus cancels, so that will become I cross k, and I cross k is equal to minus j. So the force will be acting along negative y direction. Force due to magnetic field will be acting along negative y direction. So to cancel out this force, there should be an electric field acting in the opposite direction. So the direction of electric field should be along positive y direction. Show that the frequency of revolution of a charged particle in a uniform magnetic field along the z direction is independent of its speed. The charged particle is moving in xy plane, and magnetic field is along z direction. So velocity and magnetic field, they are perpendicular to each other.